Variation of parameter is there is some formulas. So I'll tell you now. So method of variation of parameter. In the method of variation of parameter, there is a complementary function. Complementary function is CF1 plus C2F2, C1F1 plus C2F2. That is the complementary function. Particular integral is PF1 plus QF2. PF1 plus QF2, where the P can be got the value using this formula. P is equal to minus integral f2x divided by f1 f2 dash minus f2 f1 dash into dx. Q is equal to integral f1x divided by f1 f2 dash minus f2 f1 dash into dx. This denominator f1 f2 dash minus f2 f1 dash it is called as a Wronskian. So what is a Wronskian? Determinant f1 f1 dash f2 f2 dash. So if you find the determinant value of the Wronskian is f1 f1 dash f2 f2 dash. Okay. So one example I will tell you. For example, solve d square plus a square into y is equal to cosecant x. Okay. So d square plus a square is equal into y is equal to cosecant x. By the method of variation of parameters. So immediately you have to write the auxiliary equation. For a d, m, so m square plus a square is equal to 0. Next, you have to find the roots. How to find the roots? M square plus a square is equal to 0. M square is equal to minus a square. M square is equal to minus a square. So after that, you have to find m square is equal to minus a square means what is the m? M is equal to plus or minus ai. So it is the complex roots. So therefore, so it is complex roots. So complex numbers, if roots are complex, you know how to write the complementary function. So y is equal to e power alpha x, a cos beta x plus b sin beta x. This is the, in this way you have to write the complementary function when the roots are in complex numbers. Here alpha is 0, beta is a. So therefore the complementary function is y is equal to c1 cos ax plus c2 sin ax. But in the starting, I explain you the complementary function is C1 F1 plus C2 F2. So right here, the complementary function is y is equal to C1 F1 plus C2 F2. Compare these two equations. Y is equal to C1. C1 is there. For F1, there is a cos AX. For F2, there is a sin AX. So therefore, I am writing, comparing these two equations, f1 is equal to cos ax, f2 is equal to sin ax. What is f1 dash? Differentiation of cos ax. Differentiation of cos ax is equal to minus a sin ax. Differentiation of sin ax is equal to a cos ax. So next you have to find the Wronskian. What is a Wronskian? f1 f2 dash minus f2 f1 dash. So f1, you have got the value of f1 as well as f2. f2 dash, f1 dash. So everything you have to multiply, you will get a. So particular integral is p f1 plus q f2, where p is equal to the formula already, as I told you, minus f2x divided by f1 f2 dash minus f2 f1 dash dx is equal to minus f2x divided by Wronskian. Already I told you Wronskian. The denominator is called as Wronskian into dx, which is equal to integral f1x divided by w dx, Wronskian. So p is equal to minus integral f2x divided by f1 f2 dash minus f2 f1 dash into dx. Using the formula, we have to integrate it, which is equal to minus, what is f2? Already you know, f2 is equal to sin ax. So you have to write here sin ax. f1 f2 dash minus f2 f1 dash is Wronskian, that is a. So substitute here. This x, f2 x, you know, that x is what is given in the problem, right hand side, cosecant ax. This can be taken as capital X. So therefore, here we are taking minus integral sin ax by a cosecant ax into dx. So minus 1 by a integral sin ax. What is cosecant ax? Cosecant ax can be written as 1 by sin ax. So sin ax divided by sin ax will be 1. So minus 1 by a integral dx, cancel, sin ax cancel. So integral dx, if you are integrating dx, you will get x. Already there is minus 1 by a into x, which is equal to minus x by a. So p is equal to minus x by a. Q is equal to integral f1x divided by f1 f2 dash minus f2 f1 dash into dx. What is f1? Already we know, we have written f1 is equal to cos ax divided by the Wronskian a into cosecant ax dx. So 1 by a cos ax, cosecant ax can be written as 1 by sin ax dx. So 1 by a integral cos ax divided by sin ax into dx. Cos ax by sin ax will be tan, cos ax by sin is equal to cot. Sin by cos is equal to tan. So 1 by a integral cot ax dx. Cot ax, if you are integrating, what is cot x? If you are integrating cot x dx is equal to log of sin x. Log of sin x. But 1 by a integral cot ax dx. 1 by a, as it is, we have to write cot ax dx. If you are integrating 1 by a log of sin ax. 1 by a log of sin ax. So therefore, the particular integral is pf1 plus qf2. f1 is cos ax, f2 is sin ax. P value using the formula we have got, q value also using the formula we have got 1 by a square log of sin ax. So this is the particular integral. So general solution is complementary function plus particular integral. Okay. So in this way you can solve this type of problems. So next one question is, solve d square plus a square into y is equal to tan ax. For instead of cosecant, here is a tan ax. In the university or in any CAT examination, it will be specified by the method of variation of parameters. Solve d square plus a square into y is equal to tan ax by the method of variation of parameters or MVP. So MVP, method of variation of parameters. For this problem, You got to find the auxiliary equation. What is the auxiliary equation for this problem? M square plus A square is equal to 0. As I explained you in the previous problem, the same. M square is equal to minus A square. What is M is equal to plus or minus AI. So what is the complementary function? Y is equal to C1 cos AX, C2 plus C1 cos AX plus C2 sin AX, right? C1 cos AX, C2 plus C2 sin AX. So next you have to compare with the original complementary function C1 F1 plus C2 F2. What is F1? What is F2? So F1 is equal to cos AX, F2 is equal to sin AX. F1 dash, you have to differentiate one time with respect to X. So cos AX, if you are differentiating, you will get minus A sin AX. F2 is equal to sin AX. So F2 dash is equal to A cos AX. So F1, F2 dash minus F2, F1 dash. Next, we have to find, this is called as Wronskian. So F1, F2 dash minus F2, F1 dash is equal to cos AX into A cos AX minus sin AX into minus A sin AX. So A cos square AX plus A sin square AX is equal to A into cos square AX plus sin square AX. Cos square theta plus sin square theta will be 1. So using this formula here, A into 1 is equal to A. So Wronskian is A. Then the particular integral is Pf1 plus Qf2. P is equal to minus, the formula is there, minus integral f2x divided by f1 f2 dash minus f2 f1 dash into dx. Q is equal to integral f1x divided by f1 f2 dash minus f2 f1 dash into dx. So these two formulas are very important in the method of variation of parameters. So P is equal to minus integral f2x divided by f1 f2 dash minus f2 f1 dash into dx. So minus integral sin ax, f2 is sin ax, capital X is a tan ax dx, capital X is a tan ax into dx divided by Wronskian is a. So minus 1 by a integral sin ax, tan ax can be written as sin ax by cos ax into dx. Minus 1 by a integral sin ax into sin ax will be sin square ax divided by cos ax into dx. Sin square theta can be written as 1 minus cos square theta. So minus 1 by a integral sin square ax can be written as 1 minus cos square ax divided by cos ax into dx. If you separate the terms minus 1 by a integral 1 divided by cos ax minus cos square ax divided by cos ax into dx. So minus 1 by a, what is 1 by cos theta? Secant theta. So minus 1 by a integral secant ax minus cos ax dx. So minus 1 by a secant ax. If you are integrating integral of secant ax dx is equal to 1 by a log of secant ax plus tan ax. Cos ax, if you are integrating, you will get sin ax divided by a. So capital P is equal to minus 1 by a square. You got to multiply minus term with other two terms. You will get 1 by a square sin ax minus log of secant ax plus tan ax. This is the P value. Q is equal to integral f2x divided. Q is equal to integral f1x divided by f1 f2 dash minus f2 f1 dash into dx. F1 is cos AX, capital X is tan AX, Wronskian is A into dx. So 1 by A cos AX, tan AX can be written as sin AX by cos AX. So cos AX divided by cos AX will be 1. Cancel. So 1 by A integral sin AX dx. Sin AX, if you are integrating, you will get 1 by A minus cos AX by A. So if you multiply these two terms, minus 1 by A square cos AX. So the particular integral is Pf1 plus Qf2. P is 1 by A square sin AX minus log of secant AX plus tan AX into F1 cos AX plus Q minus 1 by A square cos AX into sin AX. So general solution is PF plus CF. Particular integral plus complementary function or complementary function plus particular integral. Okay. So all the problems will be secant, cosecant, cot, tan. Okay. So this type of problems can be solved using the method of variation of parameters. Okay. So another question one. Another question. Let us see another question. So solve d square plus 4 into y is equal to secant to x by the method of variation of parameters. So you know very well how to find the complementary function. First, start with the auxiliary equation. The auxiliary equation is m square plus 4 is equal to 0. M square is equal to minus 4. M is equal to plus or minus 2i. The complementary function is y is equal to c1 cos 2x plus c2 sin 2x. F1 is equal to cos 2x, F2 is equal to sin 2x. What is F1 dash? Minus 2 sin 2x. What is F2 dash? 2 cos 2x. So F1 F2 dash minus F2 F1 dash is equal to cos 2x into 2 cos 2x minus sin 2x into minus 2 sin 2x. So 2 cos square 2x plus 2 sin square 2x, which is equal to 2. Because cos square 2x plus sin square 2x is equal to 1. So the particular integral is, as I explained you earlier, the formula PQ are the same for all the problems of method of variation of parameters. So P is equal to minus integral F2x divided by F1 F2 dash minus F2 F1 dash into dx. F2 is equal to sin 2x. So minus integral sin 2x divided by the Wronskian is 2. Capital X is equal to secant 2x into dx. Secant 2x can be written as in the next step minus 1 by 2 integral sin 2x into 1 by cos 2x into dx. So sin 2x by cos 2x will be tan 2x. So minus 1 by 2 tan 2x. So tan ax, integration of tan ax dx. If you are integrating 1 by a log of cos ax. So here you have to integrate tan 2x dx. So therefore minus 1 by 2 integral tan 2x dx is equal to minus 1 by 2 into 1 by 2 log of cos 2x. So 1 by 2 minus 1 by 2 if you multiply minus 1 by 4, right? So tan means minus log cos 2x. Am I right? Tan x if you are integrating minus log cos x. Cot x if you are integrating log sin x. But tan x if you are integrating you will get minus log cos x. Minus minus cancel. So 1 by 4 log of cos 2x. This is the value of P. Q is equal to integral f1x divided by f1 f2 dash minus f2 f1 dash into dx. So Q is equal to integral cos 2x divided by 2 into secant 2x dx. So 1 by 2 integral cos 2x 1 divided by cos to x, because secant to x can be written as 1 divided by cos to x into dx. So 1 by 2 integral dx. Dx means x, so which is equal to x by 2. So the particular integral is pf1 plus qf2 is equal to 1 by 4 log of cos to x into cos to x plus x by 2 sin to x. Okay, so general solution is you have to write complementary function plus particular integral 1 pf1 plus qf2. Particular integrals you have to write with the combination of complementary function. Okay, so in this way you have to solve. This is the method of variation of parameters. So prepare